Chapter 9. We're going to talk about electrons. Electrons in atoms, and we're going to talk about the periodic table. Some more. This is perhaps an infamous photograph. That is the dirigible, the Hindenburg. It was filled with hydrogen gas and successfully made it across the Atlantic and burst into flames just as it was landing back in 1937. Killed 36 of 97 passengers. When you look at that, you think, wow, it's amazing that they weren't all killed. The passengers are in here. This is the little cabin, I guess. Most of this is just big balloon, basically. So we learned from this that hydrogen is not a good substance to make a blimp out of. Okay, so we still use blimps. A lot of times they're used over sporting events or to advertise things, but now they're filled with helium. Why do we use helium? Because helium is not very reactive. Hydrogen is very reactive. It's very flammable. Well, chemists want to know why. Why is hydrogen so flammable? Here's a modern blimp. They overlaid TRO, introductory chemistry, on there instead of Goodyear or something. This is filled with helium. Helium is very inert. It's one of the noble gases. It doesn't make compounds. It definitely doesn't burn. Why? They're right next to each other. Well, they're kind of right next to each other on the periodic table. They're the two smallest elements, and yet they're so very, very different. The question is why? And we're going to learn about that in this chapter. Are there other elements that are as reactive as hydrogen? Yeah. Other elements in group 1, like lithium and sodium, are also extremely reactive. They will react with moisture in the air. You put a chunk of sodium in a sink full of water and it'll explode. They are very, very reactive substances. Other elements are also as inert as helium, the noble gases like neon, argon, krypton, those guys. And this is, the periodic law that formed the periodic table. So we see in the far right column, the noble gases, all of those elements have some things in common. They are very unreactive. And on the left side, the alkali metals plus hydrogen are very reactive. And we're going to come to see that it has to do with electrons. The electrons help us to explain that. So models and theories are used to help us explain what is observed. So we're going to talk about some models. The two important ones are the Bohr model and the quantum mechanical model. They both propose explanations for the inertness of helium, the reactivity of hydrogen, and the periodic law. Remember, the periodic law is that when the elements are arranged in order of increasing atomic number, certain sets of properties recur periodically. So the models explain what those atoms, the electrons, are doing inside the atoms and how those electrons affect the chemical and physical properties of the elements. So you will likely find quantum mechanics to be somewhat disturbing. I guarantee you will not understand it, not fully. I don't understand it fully. Here's some interesting quotes from some very famous scientists. Niels Bohr, who developed the Bohr model, which was fairly quickly proven incorrect. He said, anyone who is not shocked by quantum mechanics has not understood it. Erwin Schrödinger, who was one of the people who developed the quantum mechanical model, said, I don't like it, and I am sorry I ever had anything to do with it. You find something and you're like, man, I do not like what I just discovered. It's kind of like cleaning an 8-year-old's bedroom and you find things. Albert Einstein, I think you've heard of him. He didn't like this either. He says, God does not play dice with the universe. Because that's what it appears, that there's this random chance involved in what these electrons are doing. So there's a fun introduction to quantum mechanics. Quantum mechanics is foundational. It's fundamental in understanding modern chemistry. And it's made a lot of things possible. By understanding why atoms do the things that they do, we can use their characteristics and create matter that behaves the way we want it to behave. So it has enabled computer technology through the use of semiconductors. New drugs have been developed using these approaches. It's pretty important.